So let's focus on the rules of integration. So the rules of integration, understanding these rules of integration will help you in whatever you do as you move up in these tutorials. So understanding these common rules in this integration will help you to understand how to do the various type of integration when they are given to you. For instance, when they give you a constant, how do we integrate a constant? When they give you anything that does not that involve a variable, how do we integrate it? Which is in the polynomial form, how do we integrate it? When we give you a function that contains maybe natural logarithm, or maybe they contain the form that's when you integrate you are going to get a natural logarithm form, how do we integrate it? When they give you a function that contains an exponential form, how do we integrate it? So understanding these rules of integration, it's going to help you to understand the concept of integration very well. So first of all, let's look at the constant rule. So the constant rule states that when you have an integral of a dx, the result is when you have an integral a dx, the result is ax plus c. This is what it means. When you have an integration of a with respect to x, it means that the a is our constant, this a is our constant, and we are integrating this a with respect to x, right? And as I said earlier on, this a, which is a constant, means that there's an x attached to it. But one thing that you have to be careful here is that the x is of power what? 0. I remember when you went to your SHS, you were told that any number to the power 0, it's what? 1. But you know that was not entirely true, because when I get 0 to the power 0, it's not going to give me 1, right? Or is it going to give me 1? Maybe you can verify it and let me know. Yeah, so 0 to the power 0 or 0 to the power 0 is not going to give me 1. You get me? So basically, any number to the power 0 except 0, it's going to give us what? 1. For instance, if you have maybe negative 1 to the power, maybe negative to 1 to the power 0, the answer is going to give you what? Negative 1. 1 to the power 0 is going to give me 1. 8 to the power what? 0 is also going to give me 1, and so on and so forth. So basically, for this constant, we assume that there's an x attached to it, but that particular x, it has a power of 0, and x to the power of 0 is going to give us 1. That's why we don't write it, we leave it just like that, right? So assume that you can rewrite it in this way: integral of a to the power a multiplied by x to the power 0 dx, and this is the result, ax plus c. This is all what this rule means. This is the reason why when you integrate a constant, you get x attached to it. So now x that I have here is to the power 0. So when I integrate it using my normal power rule integration, I'm going to get x to the power 0 plus 1 over 0 plus 1, of which I'm going to get ax power 1 over 1, which is what? Ax. And please don't forget your constant of integration, which is what? This c. So this is what the power rule means. So wherever you see a constant, when you integrate that constant, you are going to get x value attached to it. Let me use this differentiation to kind of give you more clarity. When you have a constant here, maybe a, or when you have a constant, let's use the constant k. When you find dy dx of k, which is a constant, you are going to get 0. And that same reason also applies to that of the differentiation. We assume that the x attached to it has a power of what? 0. And therefore, if you are integrating that constant, let me say you are differentiating that constant, what are you going to get? You know, we take the power, we multiply by a whole function, and then we subtract 1 from it. So let's do that. The power here is 0. So we have 0 multiplied by kx power 0 minus 1. This is what we have. And then after, we are going to get 0 multiplied by kx power negative 1, of which 0 multiplied by this number is going to give us 0. So when you differentiate any constant, you are going to get the value 0. But when you rather integrate it, you are going to get x value attached to it. So if the value is 1, when you integrate it, you are going to get what? X, because x times 1 is what? X. When the value is 2 and you are integrating 2 with respect to x, you are going to get 2x, right? When you want to integrate 2 with respect to t, the t, you are going to get what? 2t. But please don't forget your constant of integration, which is what? The c. That one is very important. Don't forget it. Yeah, so this is the whole about the power rule. So let's move to the second one, which is the whole about the constant rule. Let's move to the power rule, right? So what is the power rule? The power rule states that if you have a variable x to the power of n, of which you are integrating it with respect to x, this is what we do. This is what we do. You take the power, you add 1 to it, and then you divide by the power plus the 1, and then you add your constant. This is the reverse of the differentiation that we are working on. For the differentiation, if we have x to the power n, and we want to differentiate it, we take this constant here, we subtract 1 from here. That constant is multiplying by what? The coefficient in front of the x, right? This is what you get, and now finally we are going to get nx power n minus what? 1. But in differentiation, instead of multiplying, we divide. So what you do is that in integration, instead of multiplying, we divide. So what we do is that instead of also subtracting, we add. So you take the exponent, you add 1 to it, and you divide by it. You take the exponent, you add 1 to it, and then finally you add plus your c. That's your arbitrary constant of what? Integration. So this is what the power rule also says. And mind me, that is the basis of the integration that you are doing, and you are going to apply it anywhere that you find yourself as far as calculus 2 is concerned. So let's look at the next one. The next one, it's the natural logarithm rule. This natural logarithm rule is more or less like wherever you see 1 over x, or anything similar to that thing, it means that the resultant is going to give us what? Ln. Is going to give us ln. For instance, the integral of this 1 over x here is going to give us what? Ln x plus c. Use differentiation to verify this answer, whether you are correct or wrong. The differential of ln x here is also going to give us 1 over x. But remember that I told you when you are differentiating a constant, the result is going to give us what? 0. So now the result here that we are going to get is what? 1 over x, which further verifies our answer. I want to expand this a little bit to you so that you can get more clarity. So let's look at something like this. The whole thing that we are doing here is when you have ln x, what they do is that they differentiate here, right? They differentiate whatever is here. When you differentiate x inside here, you are going to get what? 1. And then that 1 times then 1 over whatever is inside x. So 1 times 1 over x is what? 1 over x. This is the rationale behind that. So if you have maybe ln x squared, what you are going to do is that you differentiate whatever is here. When you differentiate whatever is here, you are going to get what? 2x, right? And then the function here is x squared, so you pick that function and do it 1 over that function, which is x squared. And at our, we're going to cancel out, and we are going to get what? 2 over what? X. So this is going to be your final answer for it. This is going to be your final answer for it. So that's ln x squared. So that's the rationale behind of integrating or differentiating those ln constant. As I said earlier on, I'll find time and do a whole tutorial on that, on how to differentiate ln functions, trigonometric functions, and exponential functions. So let's get to the exponential part. So the exponential part, what we do here is the exponent of a x dx. As I said, whenever they give you an exponential function like this, you differentiate the exponent on it, you multiply by the function itself, and then you add your plus c. But since this is integration, instead of multiplying it, the reverse is what? We divide. So what you do is that when I differentiate ax, I'm going to get a. And then you place it, instead of multiplying, we divide. So now we are going to get your 1 over a exponent ax plus what? C. So this is simple as ABCD. I know you understand this. So thank you for watching, and see you in my next video.